All right, class, we finally reached the end of chapter 5. And it's kind of easy when we do each section at a time, but chapter 5, the last section, section 13, puts it all together. And so that's where it gets a little difficult, knowing what to do when. But that's the beauty of the honey-do list. And so hopefully you've got that memorized by now, because we sure have had it on the board for a few weeks. So you might be thinking, hey, Mrs. Burton, chapter 5 didn't have any story problems. Well, we saved the best for last. So we're going to come here and we're going to look at section 513, and it says using factoring to solve problems, and it's going to be story problems. Now, if you open your book to page 234 and you read that first paragraph, it says, hey, we're going to factor. Okay, so we're going to have to, we're going to solve equations. Okay, so that means, okay, to solve equations, the first thing, number 1, it better equal 0. After it equals 0, number 2, then we're going to factor. Okay, we're going to factor. We're going to x factor. Okay, and then after we factor that, we're going to use our zero product property, ZPP, to find the answers. Now, there's the one thing that's a little bit different. We're going to find out that sometimes we might reject an answer. Okay, and the reason we would reject an answer is if it's a negative number and they're asking us to solve for length or age. And hopefully that makes sense, because length can't be negative and your age can't be negative. And so you'll see that as we go through. So you know Mrs. Burton, I've got it down to a nice little list. And so here it is. Now we're going to go back to chapter 1 and use the 5-step plan. Okay, we know we always use the 5-step plan when we're solving story problems in Algebra 1. So if you need a little refresher, that's on page 27. We learned that way back in chapter 1. So let's go ahead up here and read our problem. It says if a number is subtracted from its square, the result is 110, find the number. Well, back in chapter 1, we learned how to dissect these word sentences to make a math equation. And so what is the most important word up there that I need to box that shows me equal? That's right. We know that is means equal, and that's important because that shows me who goes in front of the equal sign and who goes after the equal sign. Now, do you see an operator word up there? Yeah, my operator word is subtracted from, and hopefully you're thinking, oh wow, subtraction, order matters with subtraction. So now that we've gotten all those thoughts in order, let's see, step number 1, okay, of the 5-step plan. Determine the unknowns and define the variable. Well, if we read the last line, it says find the number. So can you guess what my let statement would be? I would say let n equal a number. Now, sometimes, step number 2, sometimes it's nice to draw a sketch. We'll see that on the next problem, but sometimes it's nice to draw a sketch, but we really don't need a sketch on this one. So now we're down to write an equation to model the problem. So how would we write if a number is subtracted from its square and n is my number? Well, we would say if a number n is subtracted from its square, well, we know we're going to have to subtract n. What are we going to subtract it from? It's squared. N squared minus n. The result is means equal 110. That was pretty easy. Okay, now that I have my equation, how do I solve it? Well, remember, does it equal 0? No, it does not. So the first thing we need to do is make this equal 0. So we're going to subtract 110 from both sides. So we've got n squared minus n minus 110 equals 0. That was step number 1 on the previous slide. If it equals 0, what do we do next? Okay, we've got an x factor. how are we going to factor this trinomial? Well, we need the factors of n squared, which are n and n. If I look at my signs, what do I know? Yeah, that back one's minus, so that means one of mine needs to be plus and one of mine needs to be minus. What set of factors are we going to use for 110? Well, 1 and 110 isn't going to work. 2 and 55 isn't going to work. Yeah, right, we need to use 10 and 11. Now, when I look at that linear term, it's negative, so that means the negative sign needs to be with 11, positive needs to be with 10. And so now it's in factored form. The whole thing equals 0. So where do we go next? That's right, each part equals 0. So we've got n plus 10 equals 0. So this n is going to be negative 10. And then on the second part, remember here's part 1 and here's part 2. On the second part, we've got n minus 11 equals 0. So n equals 11. Now, you've got to remember, what is the last step of the 5-step plan? Yes, you've got to make sure you check. So how do we check? Well, we plug those numbers back in. If I use the original equation and I plug back in negative 10, we've got negative 10 squared minus negative 10 equals 110. Well, negative 10 squared is 100. Ooh, do you see my sleeping man right there? We haven't seen him in a while. So that's going to be plus 10 equals 110. And then this checks. 110 equals 110. Well, let's check 11. We've got 11 squared minus 11 equals 110. What's 11 squared? Yep, 121 minus 11 equals 110. And guess what? 110 equals 110. So both of them check. So just remember to make sure that you check your answer in the 5-step plan. Now, let's go ahead and look at our second equation here. When I look at my second equation, it says solve using the 5-step plan. Write out each step, including a sketch of the rectangle and its dimensions labeled. So this is where step number 2 comes in. Drawing me a sketch kind of helps. So here's my rectangle, and here's what it says. The length of a rectangle is 8 centimeters greater than twice its width. We're going to find the dimensions. Remember, the dimensions means the length and width. If its area is 24 centimeters squared. Now, I kind of expect you to know something. What do I expect you to know? Yeah, you've got to know area equals what? Length times width. So, let's go back up here to the first sentence. We're kind of back in chapter 1, and let's see if we can come up with let statements. So you can either give me let statements or you can label the rectangle. So it says the length of my rectangle is 8 centimeters greater than twice its width. So who are we going to write down first? Remember back in chapter 1 we said the last shall be first. So we're going to put the width as W. If the width is W, the length is 8 centimeters greater than twice its width. How are we going to write that? Well, 8 centimeters greater means plus 8 than twice its width. Okay, so now what's my equation going to look like? Find the dimensions if the area is 24 centimeters. Well, we've already said area equals length times width, so that means we've got W times 2W plus 8. Don't forget to put those parentheses around your binomial equals 24 centimeters squared. Okay, so here's my equation. What do you think I need to do next to solve it? Yes, we've got to take care of that distributive property. So W times 2W, 2W squared, W times 8 plus 8W equals 24. Now, if we're solving, and it's a quadratic equation, what does it have to equal? Right, it has to equal 0. So we're going to say 2W squared plus 8W minus 24 equals 0. do you notice something? What's rule number 1 of factoring? Did you realize we have a GCF? We do. Now, what do we do when we have a GCF? Well, we factor it out. If I factor out my 2, what are the factors that remain? Well, we've got w squared plus 8 divided by 2 is 4w minus 12. Now, this little 2 is a problem child, but we can get rid of him easily by dividing both sides by both sides by 2. If I divide both sides by 2, it still works out nicely because now we've got w squared plus 4w minus 12 equals 0. 0 divided by 2 is 0. So now we've just got the x factor. What factors of 12 will give us that 4 as our linear term in the middle? Well, we've got 1 and 12, 2 and 6, and 3 and 4. Well, we know the factors of w squared have to be w and w. If we look at our signs, did you realize that back one's minus? So 1 needs to be plus and 1 needs to be minus. Hey, my linear term in the middle is positive, so we're going to have to use 2 and 6, and we're going to make 6 positive and 2 negative. Yeah, that GCF, factoring out that GCF makes the x factor easy. So now each part equals 0. So here we're going to get w equals negative 6, and here we're going to get w equals 2. Now, remember, we're talking length and width. So does this w minus 6 make sense? No. We're going to reject that answer because it's negative, and length can't be a negative number. So we're going to take w equals 2. Now, we did all that work. Let's make sure we answer the question. And the question was, what are the dimensions? So that means we've got to find the width, which is w, which was 2 centimeters. And then the length, well, remember, that was what? 2w plus 8. And if we plug 2 in there, we're going to get 12 centimeters. Now, remember, we've got to have a check. And the easiest way to check that is 2 times 12 equals 24, and 24 equals 24. Okay? That's my favorite problem. I would make sure we know that before test day. All right, let's go to the third type, and let's look at number 2. It says use the 5-step plan, write out each step. It says find 2 consecutive positive even integers whose product is 224. Now, we haven't seen this word in a while. Consecutive even. Okay, and we're supposed to find 2 of them. Okay, so if I need 2 of them, how many let statements do I need? That's right, and step number 1 is let statement, so I'm going to let n equal my first integer. Now, if we're looking for consecutive even integers, remember that was back in chapter 1, and we saw if we're looking for even integers, we're counting by 2's. Nicely done. So then we're going to let n plus 2 be the next integer. Okay, so there's my let statements. What's my operator word this time? Yeah, it says their product. So if we're looking for their product, we're going to take these guys and multiply. So how does that look? Well, we've got n times n plus 2, and it says is means equal 224. All right, so now what are we going to do to solve? Well, first thing I need to do is take care of my distributive property here. So n times n is n squared. And then n times 2 is 2n equals 224. Now remember, if we're solving, what's it supposed to equal? 0. That's right. So n squared plus 2n minus 224 equals 0. Now here comes the fun part. We need factors of 224 that are going to give me positive 2n in the middle. So we know it's got to be n and n. And if we look at our signs, one has to be plus and one has to be minus. Now, Here's the hard part. Now, I need two numbers multiplied add them together, going to give me positive 2. And they can only be two places away from each other, so they're probably going to be in the tens family. They're going to be in the teens. So if you play around with it for a little while, hopefully you would figure out that it would be 14 and 16. If we take 14 times 16, what do we get? 6 times 4, 24, that's 8. And if I add those together, I get 224. So it had to be 14 and 16. Which one am I going to make positive? Well, the bigger one, because I need a positive answer. Okay, so now, if we have the whole thing that equals 0, then what do we know? Each part equals 0. So that means n plus 16 equals 0. So this n is negative 16. And for the second part, n minus 14 equals 0. So this n equals 14. So we did all that work. Now, what was the question? Do you remember? It says find two consecutive positive even integers. So if you look, they're asking for positive even integers. So we're going to reject this, okay, because he's a negative number. All right? So that means that my first integer is n, and we know n equals 14, and that means the second integer, which our let statement says is n plus 2, is going to be 16. And if you multiply those two guys together for your check, guess what you get? 224. Okay, now we've got one more story problem to look at. And this last story problem has a diagram. It says solve using the 5-step plan, write out each step. It says we have a garden plot, and that garden plot is 4 meters by 12 meters. If you look at my diagram, that's the green area in my diagram. And it says that it has one side along the fence as shown below. Now, here's what we want to do. We want the area of the garden is to be doubled by adding a border of uniform width on the other 3 sides. So if you look at my diagram, we're going to add x, but we're going to add it on all 3 sides. So we're going to add x here, and we're going to add x here. We don't have to put it up here. We don't have to go here, okay, because the fence is there. Okay, so if I go through there and read that, it says that I'm going to double the area of my garden. Okay, and if I double the area of my garden, then that's going to give me the area of my new bigger garden. We're making it bigger. Okay, so if I'm looking over here, then that means I need to figure out the new garden's length and width. So if I'm looking at the width, which is right here, okay, it's already 4, okay? And if you notice, we can't really add anything on the top because the fence is there. So this is going to be x plus 4, okay? But if I look at the bottom, if I look at the length, okay, it's 12, but we're adding x on this side and x on this side. So we've got x plus 12 plus x, and if I combine like terms, that's going to give me 2x plus 12. Okay, so twice the area of the garden, well, 2 times, well, how do I find the area of the green section? Well, you already know it's a 4 by 12, okay, because it told me 4 by 12 equals the area of the new garden. Now, I went ahead and made it x plus 4. Remember, addition's commutative because we're used to having the letters in front and the numbers in back. Okay, so now let's see what the math is going to look like now that we have it set up. Well, 4 times 12 is 48, and 2 times 48 is 96. Now, guess what I'm going to have to do to these two guys here? I've got to FOIL them to find the answer. So we've got x times 2x, which is 2x squared. Outside is going to give me 12x. Inside is going to give me 8x. And then 4 times 12 is 48. So we're going to collect our like terms in the middle. We've got 20x plus 48, and then we've still got this guy over here, equals 96. Okay, so now we're ready to solve. But there's a problem. Why can't I solve this yet? Yes, it doesn't equal 0. Who do I need to move? Yeah, we need to move this 96. So I'm going to subtract 96 from both sides. And so now I have 0 equals 2x squared plus 20x. All right, what's 48 minus 96? And that's going to give me negative 48. Okay, finally, I've got a trinomial that equals 0. Now, we got a factor. Do you see it? Yes, there's a GCF. So we're going to factor out a 2, and I'm left with x squared plus 10x minus 24 equals 0. How do we get rid of that 2 in front? We're going to divide both sides by 2. 0 equals, and we've got x squared plus 10x minus 24. All right, there it is. Now, we've got our trinomial. How do I factor it? Well, we need the factors of x squared, which are going to be x and x. What do we know about our signs? One has to be plus and one has to be minus. Okay, one has to be plus and one has to be minus. So, factors of 24. That's what we've got to figure out now. Well, 1 and 24, 2 and 12, let's see, 3 and 8, and 4 and 6. So which set of those factors will somehow give me 10? Now, you might think 4 and 6, but realize I got different signs. So that means I've got to subtract them. So we're going to actually pick 2 and 12. I'm going to put the 12 by the plus sign because my linear term's positive, minus 2. If the whole thing equals 0, so x plus 12 equals 0, x equals negative 12. X minus 2 equals 0, so x equals 2. Now remember, we're talking about length and width, so we're going to have to reject this negative 12 because length and width can't be negative, so that means x equals 2. Now if I go back up here at the top and I read the question, what was the question now that I did all that work? What would the width of the border be? So we're solving for x, and we already did that, and so we know x equals 2, and it was meters. Final answer. Okay, make sure you show me a check in there. And that is our final type of story problem.